The facade pattern is a structural design pattern that describes a way to simplify your code by placing an interface between complicated logic and the clients that use it. The pattern is most useful when using third-party libraries or frameworks that introduce complexity to your code base through additional classes, dependencies, and business rules. In this video, I'm going to use the facade pattern to provide a more straightforward interface to some logic that relies on the popular Unity asset called Shapes. That way, you can see the design pattern in action and hopefully get a better understanding of how you can use it in your own code. But first, if you want more content just like this, sign up for my Level 2 Game Dev newsletter. Level 2 is all about helping you develop the skills needed to take your game dev hobby or career to the next level. Once a month, we'll send you a curated list of content that'll help you take the next steps in your game dev journey. If you're interested, visit the link in the description to sign up now. All right, let's take a look at our example project. This is the latest in a long list of prototypes that I've been working on recently. My goal for this project was to see if I could draw a mini-map for a grid-based world using the popular Unity asset called Shapes. If you aren't familiar, Shapes is a real-time vector library for Unity that was created by Freya Homer. Apologies if I mispronounced your name. I've been wanting to play around with this ever since the library came out, and this seemed like a pretty good use case. The world is generated by this script called World Grid that instantiates a prefab for each cell in a grid based on some values that you can enter in the inspector. World Grid is also responsible for sending a ping to the minimap whenever a cell is clicked. The minimap is drawn by the minimap script, which currently exposes 3 public functions: show, hide, and ping. Its main responsibility at the moment is to translate positions on the world grid to a 2D position on the minimap, as we can see here in the ping method. Otherwise, the rest of the script is dedicated to drawing the minimap on the screen using the Shapes library. And it also uses DOTween for animations. With these 2 components in the scene, a world gets generated, and I can ping the minimap by clicking on the cells in the grid. As far as prototypes go, it isn't perfect, but I'm happy with it. The code works and it gave me an opportunity to learn how to use the Shapes library. It also revealed a challenge that commonly arises when your code relies heavily on third-party libraries like Shapes and DoTween. Let me show you what I mean. Shapes uses immediate mode drawing to let you draw vectors directly from your code. Immediate mode only renders once, so in order to draw continuously, you need to draw every frame. It sounds simple enough, but there's a little more to it, and there's some gotchas to be aware of. Luckily, Shapes also includes a helper class called Immediate Mode Shape Drawer that makes drawing in immediate mode a little bit easier. All you have to do is subclass it and override the Draw Shapes method, where you can safely make all of the draw calls you need, which you can see that I've done here in my minimap class. This is great because all of the drawing logic is isolated to one section of code. But there's one thing that's still sort of bugging me. Libraries and frameworks like Shapes are often complicated because they're designed to work for a broad range of use cases. And they tend to bring that complexity to your code, even if you're using them to do something super simple, like draw a minimap. My minimap script is responsible for drawing 2 things: the background and the pings. And yet, between Shapes and DOTween, more than half of the code is dedicated to meeting the business rules of the libraries and managing state, leaving only a small portion to handle the tasks that it should really be focused on. It's fine for now, but if I continue to iterate on my minimap implementation, I'll likely want to add more functionality. And that functionality will likely come with more complexity introduced by the libraries that I'm leveraging. So the question is there a way to work with third-party libraries in a way that doesn't unnecessarily complicate your code? Fortunately, the answer is yes. Enter the facade pattern. The facade pattern is a structural design pattern that provides a simplified interface to a library, framework, or any other complex set of classes. A facade is a class that lets your clients interact with one or more libraries through a few basic functions. A common real-world example of this is a phone operator that provides a simple voice interface to the complex systems of a large organization, such as ordering systems, payment gateways, and delivery services. The operator is the facade, and the caller is the client. As the facade, the operator gives the caller access to a finite set of basic actions, like placing an order. When the caller chooses an action, the operator has the ability to manage the dependencies, follow the business rules, and process the execution steps in the order needed to carry it out correctly. In the case of our example, the Minimap class is the client. So we just need to implement a facade to help simplify how it interacts with the complicated logic that's required by the Shapes and DoTween libraries. Why don't we do that now? We'll start by creating a class that'll act as the facade. Let's call it MinimapDrawer, since at the moment, that's really the only thing I'm using Shapes and DoTween to do. We'll also have it inherit from immediate mode ShapeDrawer and override the drawShapes method. Now we can start porting over functionality, piece by piece, starting with visibility. We'll add a show and hide function, a visibility state boolean, and then add a guard clause to draw shapes. All right, looking good. Next, let's toss in the logic for drawing the background. And then pull over everything related to pinging the minimap. Now, an important distinction here is that the Minimap class is still responsible for translating world position into a point on the minimap. That business rule still belongs to the client. So the signature of the ping method on the Minimap drawer can be a little more straightforward. And all of the code that's related to our library can now safely live inside of the facade. This is probably a good time to mention that my implementation probably isn't the best. Like I said, this was a prototype. But I want to make sure that you focus on the crux of the message, that Minimap Drawer, our facade, is exposing a simplified interface to the logic provided by the Shapes API. That allows us to remove excess code from Minimap that would otherwise distract us from the business logic that it should be focused on. If you're familiar with the solid principles, you may recognize that this also enables us to honor the single responsibility rule. Minimap is responsible for managing the state of the minimap, and Minimap Drawer is responsible for drawing the minimap. All right, this looks great. Let's wire everything up in Minimap and switch over to Unity so we can take it for a spin. Just need to update the game objects, and nice. We've successfully used the facade pattern to better manage the unwanted complexity that was introduced to our code. Speaking of which, if you'd like to take a closer look at this code yourself, I've made the Unity project available to my Tier 2 patrons, who can download it using the link in the description. Just note that Shapes is a paid asset, so you'll need to own a license and import the files in order to get the full experience. It should go without saying that design patterns provide a description of common solutions to common problems. They're tools that should only be used when needed. That being said, the facade pattern should now securely be in your developer tool belt. I hope you found this video helpful. If you did, give it a thumbs up and consider subscribing to the Infallible Code YouTube channel. Also, don't forget to sign up for the Level 2 Game Dev newsletter. Thanks for watching, and as always, I'll catch you in the next video.
Special thanks to Bradley Hanson, Asier Casado Perez, Tunch Ongen, Anthony M. Davis, Michael Evans, Nanagon3, Trey Hayden, Nicholas Monter, Datwo, Saurav Chatterjee, Jennifer Irwin, Urizer, Umut Shirin, Dustin, Pietrone, and Usuf Ali Castle. Thank you for your support.